Welcome to this session on unified data observability and trustability of data lakes, warehouses, and pipelines. My name is Seth Rao. I'm the CEO of FirstEigen. What we will cover in this session is an overview of observability products, data quality products, how they protect your data. Are there any missing gaps? And how Databug addresses those gaps using machine learning, and then wrap up with some case studies. Do put in your questions as I'm going along in the chat box, and we'll try to get to them, get to as many of those as possible. If not, we'll always get back to you in person via email as well. So let's start with the difference between observability tools and data quality tools. And as was mentioned in an earlier session, the word observability has come more into our vocabulary in the last couple of years. If you look at the flow of data, invariably it has a few errors that always flow with it. Typically, it goes into a data lake where those errors accumulate, and the data warehouse persists those errors. And from the data warehouse, like a Snowflake, for example, people use it to build analytics, AI models, which amplify those errors. And then those models, with some errors in it, use new data that's coming in, which has a little bit more errors in it. You multiply them, you get results with large variability, and you use those results to make decisions. And the question is, how good and accurate are those decisions? There are two kinds of errors that contribute to bad decisions. The first is the data error itself, and those break down analytical models and analytical results. And at the point of consumption, companies typically have data quality teams where they have a fixed set of rigid standard rules that they apply to the data to see if the data is acceptable. The second kind of errors are metadata errors, and these break data pipelines, and they are usually monitored much upfront. The typical tools for metadata monitoring are the observability tools, and the data engineers want to have them, and they're typically used for Snowflake warehouse. We see a lot of use case for that off late. Now, a lot of data issues, in spite of these tools, reach the endpoint. And what's the consequence of that? We have over 40% of data initiatives that fail, and there's a drop in productivity as well, 20% drop. Now, why is it that in spite of having so many tools in both quality and observability, do we get so many errors? What is it that is not sufficient? The data observability tools are typically designed for the data warehouse right now. And they look at these 5 broad categories of issues. Now, these are restrictive. They still have to be done file by file. And validating a pipeline is pretty laborious with the current set of tools in the market. So on the whole, it is a simple tool that addresses about 20% of data issues. Now, the second set of tools, which have traditionally existed, are the data quality tools, and they are typically used at the point of consumption by the data quality team. And it looks at a set of standards which are in these 6 categories. Now, these 6 categories are different from the categories that the data observability tools look at. And the challenge here is you have to sift through mountains of data to find the rules that you want to apply to the data set to validate it. It therefore is expensive, slow, and there is a heavy dependence on the IT team. And in summary, the data quality tools are pretty static, it's not scalable, and it is highly error prone because it's highly dependent on people to interpret the data and discover what the rules are. So what you see here are the shortcomings on the data observability tools that are in the market right now and the data quality tools. Now, if we turn the lens and look at the challenges from a user's perspective, we see something interesting. There are two kinds of users: data engineers being the first one. They are tasked with building data pipelines really, really fast, lots of them, hundreds, if not thousands of them. And the challenge for them is they have to put in rules to validate the pipeline, which are manual. It has to be done bucket by bucket, and it's extremely laborious as well. Now, the second group of users who feel the pain of bad data are the data management team. And they don't have self-service capability with existing tools. So there is a heavy dependence on IT, which makes it very expensive. And it takes too much time to put any changes into production because they have to go through the IT cycle of change. So in the previous slide, we saw what was missing in the tools. Here we see what is the challenge that the user personas face. So what's missing? So if we take a quick analogy, you have currently a clunky tool, the data quality system in the end, and you have a small, low footprint data observability tool up front. It can measure the number of steps. It can tell you approximately if you're okay or not. This is a lot more detailed, bigger footprint, very expensive organization. So what is missing is a cost-effective way to determine the trust in the data throughout the data pipeline. And what is needed is something similar to an Apple Watch, maybe, that you could wear on your wrist, and it'll tell you a whole bunch of things about your health, and you can see it very quickly, and you don't have to do much work. It learns from you and it'll alert you when things go wrong. So trustability through the pipeline is a key unanswered question. Is my data trustable? Is it usable? The system that is needed is something that has to learn on its own because the volume of data is enormous. The sources, the number of platforms it's coming from is exponentially increasing. So it has to self-learn what is acceptable and what is trustable. It has to be able to detect known and unknown errors and unknown errors as well. And it should ideally be able to produce an objective measure of the trustability of data. And we developed DataBug with these criteria in mind. What DataBug does is it uses machine learning to create thousands of fingerprints in different categories of the data. You'll have time series fingerprints, multivariable spatial fingerprints, hierarchical fingerprints, and so on. And these could be thousands of them. It looks at patterns, trends, relationships, micro, macro trends, and so on. And it creates all of that into a cohesive, complex fingerprint and uses that fingerprint to validate the data consistently. Any violation from that expected fingerprint is a data issue. So it eliminates the need to write rules. It automatically figures out what is acceptable and what is not using its fingerprints. So if you look at how the market has evolved for the data validation tools, you can think of data being validated on either the metadata level or the data itself. And the tools typically are very manual, some autonomous, and highly autonomous. The classic tools that people have always used to validate data are the ETL tools. And it's just a platform. You could code whatever you want. You can check anything you want. So you could check both data errors and metadata errors, and it's a highly manual process. And then over time, new generation tools evolved. They took what ETL did and they automated some of them to start validating pipelines, semi-automatic. And the new generation of data observability tools also fall in the same category, except there is a heavy focus on metadata errors, not on data errors. And it is partially autonomous. Now, the next place where the market is going to, where the market needs to be, so the users get the most benefit of the data, is a tool that has a very high level of autonomy, automation, and it can both check for metadata errors and data errors. A tool that is unified, a tool that can act for all the way from data lakes to data warehouses, pipelines, to the point of consumption. And it can look for all kinds of errors. And Databug falls in that category of tools. Now, data trustability and observability is the key function of Databug. It does not try to do too many things. It tries to do one thing and be the world's best at that one thing. Databug observes large, if you're looking at S3 buckets, or if you're looking at projects with hundreds of files and tables in it, Databug will look at the entire file, project, subdirectory, and tell you what the data trust score is. You can follow how the data trust score is evolving over time. It'll give you a number from a 0 to 100. You can drill down and see for different tables what the data trust scores are. You could also drill down further to an individual table and see that not only can you see the aggregate data trust score for the entire table or the file, you could also see the data trust score for the different dimensions that people use to measure the quality of data. These are the standardized measures that we are all used to. Uniqueness, consistency, completeness, conformity, anomaly, and so on. So Databug gives you the data trust score for every table for each of these dimensions. So you as the user will be able to see exactly how many records have issues, and you can pinpoint what those issues are as well. And Databug also has enabled the ability to self-serve. Trustability and observability should not be just the domain of the IT team or the data engineering team. Ultimately, the consumer of the data should feel extremely comfortable. They can trust the data. So the users can come, for example, in Databug, if the end user gets an alert that there is a duplicate, they should be able to come and they will be able to see what exactly the duplicate is, which microsegment of the data had the duplicate, and they have the ability to give a feedback, whether that is acceptable or it's not acceptable. So Databug makes it very powerful. It automates observing data. It automates your ability to trust your data. And it gives the users, the end users, the ability to give a feedback to the data tool. This feedback automatically enhances the fingerprint that Databug stores for each table and file individually and uses that to validate the data. So the fingerprint evolves as your data evolves. So you don't have a fixed, rigid system of rules the way data quality tools have. And unlike the data observability tools, which focus on metadata, Databug goes beyond and looks at the data itself and whether that data can be trusted. Let me share a few quick case studies. Here is a customer of ours. They are in the retail space and do a lot of retail analytics of traffic data. And they needed high accuracy because those analytics were the product that they were ultimately providing to their customer, and it impacted the customer satisfaction and revenues. Now, the technology challenge was on GCP cloud, data from hundreds of countries. IoT sensors were sending in data. They could have errors in it, and they had quite a bit, and they had to check if of the 75,000 exceptions that they were getting on a weekly basis, how much of those were correct and how many were true errors. They had a large team that had to look at the error messages individually, manually, and review them. So in the end, they just did not have enough time to review all, all, all the errors. Now, Databricks was brought in. It automated error detection, and it reduced the false positive alerts by 70 to 90%. And it was also able to increase the analyst productivity enormously because it has automatically eliminated a whole bunch of false positives, and they were able to go through a lot more issues every hour as well. Another big customer, a big bank of ours, huge team of data quality experts, and the data lake had very low data quality. They also had concerns in their existing environment that there was excessive data movement, and a lot of unexpected errors were still slipping through. They had multiple systems, and they were having issues validating large volumes of data. The validation rules that their data quality team would create were also not portable. They were very system specific. The whole process was, of course, laborious and time intensive. So with Databug, in addition to the metrics that the bank itself had, AI and ML capabilities of Databug recommended the rules that they need to put in. It is designed to handle large volumes of data. So over 1 billion rows could be handled in less than 30 minutes. It gave a huge boost in productivity, and they were able to do the same job with fewer analysts. Those analysts could be used productively somewhere else. And this also helped them in reduce the cost. So they were able to get high quality data, which means they reduced their risk, and they were able to also reduce their cost at the same time. Now, one last use case, and then we will wrap this up and open it up for Q&A. Another company in a completely different space, in the healthcare space, they had hundreds of files that came in from multiple sources, and they had to validate millions of records in real time. And the problem was unexpected errors were slipping through. Errors that they were not foreseeing were slipping through. They had much more data than the number of SMEs that they had that they would support them. So they did not have a comprehensive set of rules with which they could validate the data. And they did not have enough IT resources who would take those rules, which are already incomplete, code them, and constantly update them as the data itself evolves. So that's a twofold problem. So with Databug, they were able to automatically and autonomously validate their S3 lake. They were able to onboard thousands of data sets in less than 15 days, which is 2 resources. If you could imagine a typical company, if they had to onboard 1,000 data sets, it's a few man years of work. It's not that easy. Because of automation, Databug accelerated this enormously. And very, very quickly, they were able to catch unexpected data errors within 7 days of production. So you're getting value from the software very, very quickly. They were able to manage error propagation and catch errors upstream in the lake itself before it gets through the function. And because of the automation, the onboarding time was reduced by over 90%. So how should the ideal solution look like? The ideal solution should monitor both data and metadata, and it should monitor it from data lake all the way to the consumption, L to C, throughout the pipeline. It's not sufficient just to monitor metadata like the most prevalent observability tools do. It is not sufficient to measure just the data like the data quality tools do. Need to do both, and it needs to be automated. What Databug has done consistently for all the organizations where it has been deployed, it has reduced error by over 80%, reduced cost by over 50%, and people have been able to onboard new data sets in a fraction of the time. So time to value for your data is very, very high. Databug will take man years of work and reduce it to just a few hours using machine learning and automation. Now, I'd like to announce that we are introducing a free community version of our software. It is available from August 31st. And if you'd like to get it, please let us know. Get on the email list, send us an email. And what you will get is absolutely no coding needed. You could point it to any data lake, warehouse, and you'll be able to constantly track the profile of your data, an objective data trust score at a table level, and data trust score for the different DQ dimensions, the ones that I had shown you in the slide before. So with that, I'm going to stop and open up for any questions. And I also forgot to mention, if you're interested in seeing a demo, please visit the vendor room. You'll see a demo of this and contact us for a live demo. So I see a question here. Can Databug perform a data completeness check by matching counts between source and destination, Aurora and Snowflake? Yes. Databug can match data sources on completely different platforms, no concerns. In fact, one of our customers, a very large high-tech company in the Bay Area, Fortune 50 company, this is literally their use case. They have about 700 tables that they move from Teradata to Postgres every night. And from Postgres, they validate the data and use it for analytics. And that information is presented to the Wall Street. So they have to be absolutely certain that the data moved accurately from Teradata to Postgres. So yes, two different platforms. Databug has a very high horsepower to validate the data. We'll do it, yeah. And if you're interested in seeing what are the different data sources that we can handle, that information is available on our website. Pretty much all the modern data sources that you see will be able to validate. Okay. Any other questions? I see a few that have come in here. Actually, there's a follow-up from Gayatri, and let me answer that before I jump on to some of the others. If Databug can provide insights by reading data, should there be a PII or SPII concern? Great point. Quick answer is no, for the following 3 reasons. If it will give you any comfort, we are used by the largest banks in the US, largest banks in the Middle East, and largest banks in Africa as well. And being financial services organizations, the scrutiny on PII data is extremely, extremely high. We have cleared that high bar and have been deployed in production in those places. Now, should you be concerned about PII? And the answer is no, for the 3 reasons. Number one, the people who have access to the data can be classified to have access to parts of the data, depending on their access credentials. So you have already filtered who can see the data and who cannot see the data. Number 2, the PII data can be masked. So even for people who see the data, they might be able to see that a certain record has an anomalous, let's say, loan value, if you allow them to see a loan value. But you probably don't want them to see their social security number or any other identifying information or an email or phone number or whatever it is, right? So the analyst probably just needs to make sure that that loan value is accurate. They don't need to know the PII details. So you have the ability to mask it as well when it can be displayed. And thirdly, and this is something nobody thinks of, but it's very important, is oftentimes people can, every other tool, you can write an SQL query and pull out records. You could say, show me the data with the largest credit card number, or the largest credit limit, right? The entire record shows up. It's a very innocent query, but a lot of information does show up, right? So what we have done is, in addition, if there is any sensitive information, that information is made fuzzy. So the user will actually not be able to take that and go use that credit card anywhere else. So that's the third level of protection that we provide, which has been appreciated by the banks that I just mentioned earlier. So there are multiple layers, multiple walls that will prevent PII data from escaping. All right. Another question is on the level of automation. In data trustability, there are, and you will see this when you go to the demo, you have two levels of data trustability that Databug looks at. At the very first level, it's essential and foundational data trustability. Things like, are there too many nulls that we were not expecting to see that has just shown up? Are there duplicates? Is the format okay? Or what would people typically refer to as technical checks? And Databug automates that 100%. In literally 3 clicks, you can point to the data source and say, run. You don't have to tell Databug what kind of data it is, whether it's a financial data, healthcare data, what retail data, it does not matter. Databug looks at it, your data, it creates thousands of micro fingerprints, and it uses that to validate the data. So you have entirely eliminated about 70 to 80% of your heavy lifting by Databug automating that. And the second level of trust verification that Databug does is more advanced. It looks at 5 different kinds of anomalies. When people refer to anomaly, they usually refer to a value anomaly. So 5 different kinds of anomalies. It'll look at volume anomaly, number of records, okay. It'll look at intercolumn relationship anomaly, which nobody does. It'll look at drift anomalies. If the patterns in your columns are changing, it'll pick it up. It'll look at value anomaly, and it'll also look at distribution anomaly. Databug automatically discovers microsegments within your data. For example, one of the pharma companies we worked with, their sales data had about 12,000 microsegments. 12,000 microsegments. Because if they took the number of products that they sell, multiplied by the zip codes by they sell, multiplied by the number of physicians who are referring them, and so on, you literally have over 12,000 microsegments. And Databug has the ability to go down to each of those microsegments and create a micro fingerprint for that microsegment and uses that to track and validate that data. So extremely powerful, extremely accurate. The moderator is giving me a heads up that the meeting will end, this session will end in 30 seconds. So if there are any more questions, please shoot me an email. It is seth.rao@firsteigen.com. And the moderator, if you want to close the session, please feel free to do it. We will answer the questions and via email.